Okay, so this is the third time I've started recording myself filming this problem. The first one, my recording software was actually just failing a bunch. And the second time I approached it, I spent an hour and a half recording myself with the solution, and I actually completely approached it in a way that would not solve the problem, fundamentally would not solve the problem, and there was really no coming back from it. So I just quit. That was actually just like a few minutes ago. So the first time we see a duplicate character should be this, oh my god. So I'm starting over. And the reason I'm mentioning this is because I want to, I guess, normalize failure or make it be seen that it's okay to spend a lot of time on problems that don't work. It's normal, it happens to everybody. The other reason I'm mentioning this is because if this time I solve it, that's because I've already seen this problem twice. And even more times before that, but I've forgotten the answer. So I've actually had time to think about this problem for a couple, or at least for a day already. And I also just implemented a bad solution, which also lets me know why my approach was bad. So overall, I have some familiarity with this problem already, and I'm not just starting this recording now. So this problem, longest substring without repeating characters. Hopefully I include things before this part where I explain the problem. Anyway, the way that we're actually going to approach this problem is using a sliding window, and that is going to allow us to find the longest substring in a single pass over the input string. So what I mean by sliding window is if we look at this example here, we start with a window size of 1, and that means we start at index 0 and we end at index 1, or the second character. So our window is spanning the length of 1, and it's just the character A. And then we increase our window size because we don't have any duplicate characters in this window. We increase our window size in the forward direction. And then now we have AB. So with this window, we also do not have any duplicate characters in it. So we can increase our window size to ABC. Again, our window does not have any duplicate characters in it, so we can try to increase our window size again. Now we try to span ABCA. However, now we have a duplicate character in our window. So we need to decrease our window to not include duplicate characters anymore. In my previous solution, I tried to start over here. Not the right approach. We just need to decrease our window size from the left. So like I said, when we were trying to have a window of these 4 characters, all we need to do is move our starting index up by 1. So now we have a window of BCA, and we again don't have any duplicate characters, so we try to increase our window size in the forward direction. So now we have BCAB, again we have a duplicate. Now we shrink our window size to just these 3 characters. The reason we do that, we move our starting index up until we don't have a duplicate character anymore, which is the character that we just ran into. So that works really well on this string because it repeats in a nice way. I think it's sort of obvious how it applies to this one as well. We have our window size of 1, we try to increase it by 1, we end up here, and then we decrease our window size. We start here over and over until we get to the end of the string, and we end up with a window size of 1 being our biggest. And then this solution might be a little more interesting than the first 2 examples. So we start with P, have our window size of 1, we try to increase it, PWW, we have a window size of 2, and then we try to increase our window size again. We found a duplicate character. But now instead of moving our starting index up by 1, we actually move it up by 2, because we don't just want to start at WW again, because we already have a problem. So we move it up to the character that is the problem, which is this W here. So we try to move past it. So again, we start our window at the character W. And now our window size is 1. And we do have to store somewhere that our longest substring was 2. That's okay. We'll figure that out when we're coding it up. And now we start this W. We increase our window size by 1 in the forward direction. We have WK, again, no duplicate characters, WKE, no duplicate characters, WKEW, no duplicate, or sorry, we do a duplicate character now, and then we just shrink our window by 1. We only have to move it up once here, because W was the problem. And now we have KEW, totally valid window, also totally valid to compete with WKE for the longest substring. Okay, so this solution works for all the examples provided. To try to think of maybe a solution that it wouldn't work for, although ideally there is not one, how could it happen that moving the starting index forward would skip over a potential longest substring? I think it's not possible. I think the solution works. I don't have like a mathematical guarantee, but I think the solution works. So to start looking at how we're going to code up this problem, I think the way to go about this is a recursive function. And let's just start coding up a little bit here. So longest substring is the name of our function. It's going to take some parameters, and it's going to be a function. Okay, so the parameters that it takes is possibly the entire string. It's definitely going to need some type of string as an input. And then I think it would need the start index and the end index of our window. End index. And at some point, we need to keep track of our longest substring. I don't think that needs to be a parameter. It depends how we implement this. I don't have it concretely in my mind yet, so I don't necessarily want to include it as a parameter yet. So let's think about how this actually works in code. So if we pass in the entire string, and our start index might be the first time it would be 0, and our end index would be start index plus 1, which is 1. So those are going to be our default values. And we'd look at our window, which is from start index to end index, and we would check, hey, do we have any duplicate characters? For a window size of 1, that'll never be true. We'll never have duplicate characters. So we'll try to increase our end index by 1. So then we'll call longest substring again as a recursion. We're going to pass in the same string, and our start index will be the same. Our end index will be increased by 1, and I think that'll work. Part of me wants to start trimming off characters from the string, but I don't think it's necessary. I don't think that's a necessary or even good optimization. I don't think that makes the code any simpler. I want it to make the code simpler, but I don't think it does. I think the only thing that's going to change here is our start index and our end index. So let's move forward with that in mind. And if we do find some cleaner code solutions in the future, we'll try to implement those. But let's start with what we have here. So like I said, we need to look at our first character, we need to look at our window and see if we have any duplicate characters in it. So what I actually want to do here is I don't really want to take a string. Or do I? I don't love this. I don't love this because this requires more looping. I wonder if we need to introduce a hash map here to keep track of the characters in the string as opposed to looping over them every single time, because we don't need to do that. So we actually do need, I think, another parameter here, which is the map of characters that we have seen. We're just going to leave that as an object for now. We're not going to use map because I prefer to use object in JavaScript most times. But you can use map. It's pretty much the same. So let's see how this works with the scene object. So when we have a window size of 1, we're going to put that character into our scene object. We'll increase the window size. We'll put our new character into the scene object if we haven't seen it before. Otherwise, we're going to not change the scene object. Let's start coding this up. I think we're good already. I think we just need to flesh it out and get to that solution. So our general approach, like I said, is checking if the the character that we're at, which is like our end index, the new character that we're adding by increasing our window size by 1, we're going to check that new character and see if we've seen it before. I know we haven't added anything to it yet, but this is our general solution. So we have seen character before. If scene of, we need to look at our current character, like our new character, or the character at the end of, let's call it end character, is going to be string at end character. And then we have seen it before if this object contains this character before, or if we've added this character to the object before as a key. The value is probably just going to be true. So now we know if we're whether or not we've seen a new character before. But let's assume that we haven't seen a new character before. So actually just going to fill out this else branch first, and then we'll deal with what happens if we have seen it before. So if we've not seen the character before, which is a good thing, we can increase our window size. What we're going to do is add our character to our scene object. So scene of end character is going to be true. So for example, looking at this input here, when we start, we're going to be looking at the full string. Our window size is just going to be the character A. So we're going to add A to our map, or our object of scene, and we're going to set it to true. So we've seen A. Great. And then we want to recurse. So we're going to call longest substring on still same string, and then our scene object, which is changed. And then our start index stays the same because we haven't seen a character before, or haven't seen this character before. And our end index goes up by 1. Perfect. And now, how do we handle if we have seen the character before? So like I said, we're going to try to move up the starting index. The start of our window should move forward if we have seen this character before. And it should move to the index at which we have seen it. And since we're not actually storing that, we would have to loop through the string, but we actually could store the index in our object instead of just storing true, because true isn't very much information. But we could store where we've seen this. So now our object is going to look like, so for the example here, our object is going to look like A of 1. So this is where we've seen it before. This is at the index 1. So by the time that we've seen A again, our window is going to look like this. And what we should do there is to move the beginning of the window forward until until A is not in our window anymore, the first A. So to do that, we set our start index to the index at which we saw A before plus 1. So our new start index is going to be, it's going to be scene of the character that we're currently on, which is end character, plus 1. So that's our new start index. And then we're actually going to modify the scene array, the scene object, and we're going to change where we've seen that character, and we're going to set it to the index that we're on right now, or the end index. So scene of this character is now end index. So what we've done is changed our start index. Using this example, what we've done is change the start index to 0 plus 1. So we moved our start index here. And then now we're going to change where we've seen A before to be index number 4, or sorry, index of 4, which is true going forward. And we're going to completely forget about the time that we saw A here. And then we're going to recurse again, almost exact same way as before. We might be able to simplify this. Of string, seen, new start index, and end index plus 1. I believe we don't need to do all this work here. I think we can actually move. Let's go ahead and make this simplification right now. Because we're actually changing start index here, we're reassigning it. And also, this one, line 12 and line 14 are duplicates. For both cases, we need to change where we've seen this character, which is great. So the only thing we really need to do is, if we've seen the character before, move our start index forward and save where we just need to move our start index forward before reassigning where we've seen our current character, because this assignment on line 11 relies on the knowledge of where we saw this character before. Okay, so there's one thing I'm worried about here as I'm thinking about this. And that, what was it? What was I worried about? Oh, I think we're not handling our base case. What happens when we get to the end of the string? And how do we keep track of our longest substring as we're going along this? Because at some point, our window size is going to shrink again, which is okay, but we want to keep track of times where we've had a long or large window. So how do we go about doing that? When we're recursing, the only way to store that information is in a parameter. So let's go ahead and add that extra parameter here that's going to store our size, or our max size so far. So the default max size is going to be 0. And when we recurse, we want to compare our max size. So if we have to shrink the window, we want to make sure that we've kept our max size. So in order to do that, when we're shrinking the window, we want to check if our current window size is bigger than any max size we've seen before. So to do that, we're basically going to say if end index minus start index minus 1, because we have too big of a window at this point. For example, we know that if we have seen this character before, our window size is 1 too big. So we're going to subtract an additional 1 here. If this number is bigger than our max size, so let's just call this window size, is end index minus start index minus 1. And if our window size is larger than the max size that we've seen before, then what am I doing? Max size is equal to window size. So this is how we're going to store our maximum size as we're going along. So here we go. We need to pass our max size forward through every time. We need to pass our max size in every time as well. Okay, so now how do we handle our base case? What do we do when we get to the end of the string? And we know we're at the end of the string when our end index is equal to the length of the string. We're at the last character. We're looking at the last character when our end index is 1 less than the length. But we haven't processed that character until we try to increase the end index again and try to go longer than the string or past the actual length of the string. So I believe our base case can be end index is equal to string.length. So once we try to access a character that's not in the string, we try to go past it, then we just want to return the max size that we found so far. But this is actually missing a piece because we might hit the end of the string without ever changing max size, without ever assigning it to anything. Because if the entire string is a completely unique string, no repeating characters, then we'll never have to decrease. We've never seen a character before, so we'll never set max size. The way to deal with that is maybe instead of returning max size, we have to do the comparison here. There must be a better way. We could return the current window size. We could return the current window size, but I don't think that's the right answer either, because max size might be bigger. So we need to return whichever is bigger of max size or window size. So math out max of, let's assign window size every time. It's a quick math operation. It's not a big deal to have it available always. Math out max window size versus max size. So now we have our base case covered. We have the case covered where we've seen a character before. We have the case covered where we haven't seen the character before. I think we've got everything covered. Probably wrong. But let's go ahead and let's run the test case through because I'm trouble keeping everything in my head at this moment. So let's try to submit this problem. So in the actual function that we need to implement, we're going to call along a substring. We're going to pass in the string that they give us. And everything else has a default parameter. So we're good to go. Cool. This doesn't surprise me too much. End character is not defined. Sweet. Oh, my goodness. This should have been end index. Okay, so we got the right answer on the test case. Doesn't mean we're going to get the right answer when we submit it. Let's give it a go. Okay, so we are only off by a 1. I wonder why that is. Let's think about it for just a moment. Our window size then is 1 minus 0 minus 1. That's wrong. Our window size is actually 1 to begin with. It is only here that we need to subtract our window size minus 1. We don't need to do it out here. So I shouldn't have called that window size to begin with. This might actually just be the problem. Yeah, that was just a mistake. Neat. Oh, Cheeto. Maximum call stack. Oh, okay. What's happening here is they're passing in the empty string, and since we did equals equals equals, it's going to recur. What am I thinking? It's going to call this function over and over again, but the end index will never be 0. So actually, we can just do greater than equal. Can't backspace. Okay, what is happening? Great. So if end index is longer than string.length, let's actually see what happens with an empty string here. For this example, it would immediately hit this if statement. Our window size would be 1 minus 0, which is 1, and then we would return 1, which is actually completely wrong. The way that this could handle 0 is that our start index has to start at 0, and our window size would be 0, which is fine. We can do that, and then we can still keep this being triple equals. And what's going to happen here? Actually, no, this is actually how it should go, because in the first example, we would never set that character at the 0th index. It would never make it into our scene object. So that's really important. I'm not actually sure how we were passing the test case there, but this way our character at index 0 will make it into the scene object, and then we're going to recurse with the string end index plus 1. I think this is just fine. We're going to run the test case just in case. Great, let's submit again. Okay, so we're failing immediately. We output 2. So what's happening here, I made this mistake earlier, I made it again. That's okay. So what happened, so I think this is gonna add some clarity to our problem here, definitely. So what's happening, oh my goodness. So the problem here is that we're assigning to an index. We're assigning the key to an index here in our scene object. And that means that at some point, or sorry, for the very first letter, it's going to be 0. And 0 is falsy in JavaScript. But I'm treating has seen character. I'm just putting it directly in the if statement, which means it's going to convert that index to a true or false value, and 0 is falsy, even though we have seen a before. Because it's at the 0th index, I shot myself in the foot. So basically, has seen character is this is, I believe, not undefined is one way to do this check. Because if we haven't seen this character before, it will be undefined on the object. The other thing to do, I think, is we could compare it to say greater than equal to, or greater than or equal to 0. I believe undefined is maybe like false when you make that comparison. I think because it ends up being not a number or something like that. But I think this is more explicit. Let's go ahead and see. Let's go ahead and see what's happening here. Cool. What's really good here is that we already console logged everything a bunch. So we're putting out 2, should be 1. Why might that be? Is our max size ever hitting 2? Max size is 1. No. So what's going wrong, I would guess, is that we're returning a window size that's too big. Yeah. If our start index is 4, our end index is 5. No, 0, 1, 2, 3, 4, 5. That's actually right. That's not a valid end index by the time we get to the end. I do think we need to subtract 1 here. I feel like I'm in a loop. I've entered the loop. I think this all this could have been solved. I think I confused myself a while ago. I don't know how I'm going to handle this video editing it, but I think we're redoing steps that were actually right the first time, but I confused myself because of this this Boolean check that was incorrect. Or not, I don't know. ABBA, max size is 2. So good, our max size is never wrong. But our start index of being 1, and our end index is 4. So that should not have happened. So why did that happen? Why did that happen? I'm going to guess. It looks like we didn't reset the time that we saw B twice. So how come we didn't reset when we saw B again? So our starting index would have been 0. End index 1, we should add B to our scene object. End index 2, we should have seen B before. Our end index was 2. How come we didn't reset our start index? The first time this even printed out, we saw AB, start index 0, end index 2. Right on. That's what we expect. Window size was 3. Also correct. And then we would have set our max size to 2, which is correct. And then we should have set our start index to be scene of B plus 1, which would have been 0, 1, 2. That's not right. This isn't correct. Hold on a minute. Yeah, no. Sorry, it was 1. And we should have set it to be 2. We also need to clear everything in the array, or everything in our scene object when we move our start size up. That was something we forgot to do. That's fine. Totally fine. So I'm looking at this and I'm thinking, how come our start index didn't move up? It looks like our start index, it got moved to 2. So how come? Oh, no, that is exactly the problem. That's exactly the problem. Our start index went down, and that should never happen. And that happened because we did not clear A from our scene object when we found B as a duplicate. We moved our start index up, but we didn't clear. Yeah, that's exactly what happened. We did not clear our scene object up until the window. And I wonder if there might be an optimization of this, but you don't necessarily need to clear any of the, we don't necessarily need to clear the scene object, the keys. We might just be able to do a comparison check here of if this index is greater than or equal to our start index. I think this also handles our problem earlier of has scene character is greater than or equal to 0 would be true, and undefined, however, is not greater than or equal to 0. So anytime it's undefined, I think we'll get false, which is good. So we've not seen that character before. So in this example, when we hit A again, our object is going to have the key of A and the value of 0 because we saw it here. But our start index is going to be, I believe, this B here. So we're going to ignore the fact that we've seen it before. And this is actually going to be false. We're going to say our int character, which is, it's going to be 0. Sorry, that value here, scene of int character, is going to be 0, which is not greater than our start index. So we're going to say, oh, we haven't seen this character before. We're going to skip this logic, and then we're just going to reassign the value to be the index of our new A, which is 0, 1, 2, 3. Let's go ahead and submit. Whew. Output limit exceeded. Oh, is that it? Output, I wonder, I don't know what that means. But let's give this a spin. Hey, we did it. We did it. Okay, so that is amazing. Really happy about that. Our memory usage is apparently higher than others. 44 megabytes? I guess perhaps there's a really long string in there. But yeah, let's see. It's going to be really hard to refactor because I'm a little burnt in the brain right now. But maybe there's some things we could do. First thing I want to do is put this back into one line. Let's see, another thing. Is there anything else we can do? We could also merge this into a single function. but I already showed that in a previous video, so I don't need to show it in this one. I don't like how many arguments this requires. It could probably be better. I need to take a break. I don't see any immediate things to get us faster. It seems like maybe there is some optimizations here. Perhaps like not continuing to search once the start of our window is smaller than, or if our max size is bigger than the remainder of the string, we don't need to continue anymore. That maybe could speed us up. I kind of want to take a break, eat dinner. I'll come back to this. If I see any optimizations, I'll make them. If not, that's the end of the video. I think part of the reason that this solution is not as fast as some of the other submissions is because we're doing recursion. Same for memory. Because we're doing recursion, it stores the entire stack in memory. And also all the function calls can slow down the performance of the program. If we did this iteratively instead of recursively, then I bet this runtime would get a lot faster, and I bet the memory usage would go a lot lower as well. Typically, I don't care much for optimization like that because I kind of prefer the code to look like this. Recursion makes more sense to me in my head. But maybe I'll implement this iteratively just to show you how it goes. It might be a simpler solution, to be honest. Quite likely. Maybe we'll throw that in at the end of the video, just for a little fun. If you don't like it, don't stick around. If you're happy with the solution, good, that's great. Me too. But I'm going to show another solution after this one. Okay, so let's solve this problem using an iterative approach instead of the recursive one. So we're actually going to leave our old code here for just a second so that we can reference it and hopefully finish this solution a little bit faster. So we're going to need kind of the same variables defined. So let's see, we need our scene object, we need our start index, we need our end index, whoops, a daisy. We need our max size, which also starts at 0. So we're just initializing all these variables to begin with before we enter a for loop. So basically, I think what we're going to do here is, and how are we going to approach this? I think we can actually, instead of defining end index, we're going to say that end index is the for loop condition, while end index is less than, we stop when the end index is equal to s.length, and oops, we go until, sorry, what am I thinking? End index plus plus. Okay. And then in this loop, we're basically going to do the exact same logic. I could maybe just copy it one for one. I'm not entirely sure. Let's go ahead and do so, and then make the changes that we need to make. So boop, 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 down here, let's indent this properly. We're computing our window size. This should be exactly the same as before. If the end index is equal to string.length. I don't, let's see here. I don't know if we want to do this or not. We could use a while loop instead, because we're going to have like conflicting because we don't want to return here, definitely. But we might change the max size. We could also change the max size every time. It's not going to be that big of a deal, to be completely honest. Maybe that's what we'll do, is update the max size on every loop if it's larger than the, sorry, we'll update the max size if the window size is larger than the current max size. Otherwise, we would exit the for loop and then potentially compare the max size to what the last window size would have been by comparing string.length to the start index as it would have been left after exiting the for loop. Not a big fan of that, to be completely honest. Let's just update the max size every loop. I don't think it'll be that big of a deal. So basically, max size is equal to math.max window size minus 1 or max size. We're just going to update it every single time, no problem. And then we get our end character, we get our has seen character, and if we've seen the character before, if window size is greater than max size, then we update the max size. But we don't actually need to bother with this anymore. So that's a little bit simpler. We just change the start index. Same logic here. And we don't return anymore. Basically, this is all fine because what's going to happen on the next loop is end index is going to increase by 1, just like it did in the recursive solution. So I believe returning max size might just give us the... I'll create some space down there because I'm tired of coding at the bottom of the screen. I think this will quite possibly just give us the answer already. And this is honestly, I want to say, much simpler than the recursive solution. It is a lot of mutable variables, which can be confusing, but I think this for loop is simple enough that I don't mind all the mutability, all the reassigning of values. So let's go ahead and run this on the test case and see where we're standing at the moment. Sweet. So looks like to me, it seems like our max size was never reassigned because, yeah, this almost seems impossible. How did we output 0? Oh, sorry, this is wrong. While end index is less than string.length. So once we, what am I saying? We need to change this comparison here to not be triple equals, because that will never be true. Well, at least except for an empty string, but basically this for loop should run until the end index is past the actual last index that you could get out of the string. Cool, so we got ourselves a runtime error, string is not defined. That is totally true. Is this the only time that we use string? I'm going to change this. Whoops. Let's change that back to string, and let's change the argument here to string. I think that's the right way to go about this. Cool. Got ourselves another little error. That's because we changed string here. Okay. We have our test case working. Will we get the submission correct? Okay, input of a space? What? Is that allowed? Space is unique. Expected 1. Yeah, that's good. I expect 1 as well. So what did we do wrong? Whoop. Okay. So we did not increase our max size, it seems like. So how could that have happened? So let's say we get through our for loop. The first loop, and index is 0, and our max size is going to be set to window size -1, or max size 1 minus 0 is 1 plus 1 is 2. Wait a second, sorry. The very first loop, end index is 0, start index is 0. So 0 plus 1 is 1. So math.max should be set to 1 immediately. So that's interesting. Which means there's no way we could possibly output 0. So I'm clearly thinking about this wrong. Something's wrong here. I want to say it's this condition again. At end index equals 0. End index is less than string.length. So the length of that string should be 1. And end index starts at 0. So 0 is less than 1. And then we go into the for loop. Window size is 0 minus 0 plus 1, which is 1. Math.max of window size -1 is... so this is not the correct max size. Yeah, okay. This should not be window size -1. I think we should set it every time after has seen character. So here's the deal. We need to subtract 1 if we've seen the character. Otherwise, we set max size to be window size if window size is larger than max size. So what we could do is subtract... Okay, I said I wouldn't do this earlier, but I'm going to do it. Number of has seen character. So what this does basically is it's going to convert our Boolean of has seen character into a number. And so if has seen character is true, it will be 0. And if has seen character is false, it will be 1. Sorry, I said that wrong. If has seen character is true, turning it into a number will be 1. And if it's false, turning it into a number will be 0. So window size, so subtracting 1 from window size if we have seen the character before, which is exactly what we want to do. Great, so our solution worked, but again, we weren't actually any faster than before. To be honest, I'm a little bit surprised. Yeah, our solution did not get any faster. Our memory usage did go way down, however. Way down. So that's a plus. Yeah, we're not getting much better. There might be an even better way to solve this problem. That'll be interesting. I'm going to delete this code. I'm going to look into if there's a better solution. I might not show it on camera if there is, to be honest, because I think this video is long enough already. And I'm pretty happy with this solution, to be honest. I think it is, I mean, clearly we've shown it right here, it being time complexity of big O of n, so just a single loop through, which is really fantastic. I'm totally happy with that. So anyway, this video is going to continue or it won't. Thank you for watching. Hope you learned something new. Hope you enjoyed it. If you have any questions or any feedback, please leave them in the comments below on YouTube. And you can find this code on GitHub, by the way. I'm putting all these on GitHub. What else do I want to say? I don't know. Thanks for watching. Bye. I just wanted to make a quick jump in here to say that the way that we solved it is actually the approach 3 in the solution tab, which is sliding window optimized, which is the fastest solution that they actually provide for us. So I'm not entirely sure why we're not in the top 10% or even what's happening. I don't know necessarily why we're not one of the fastest submissions. It could be something I'm doing. I don't know why we're not in the top 10%. It could be something to do with the variables that we're using. We could maybe be using less, or I'm not exactly sure what it is. Maybe using a map instead of the object would make it faster for the scene. variable. I'm not really sure. I'm not going to worry too much about it because I think we did implement the fastest solution, so I'm pretty happy with that.